The next attribute we're going to look at is the file name attribute. So again, in our list, you will see again we looked at the header, we looked at this standard information attribute. Now we're going to look at the file name attribute. Its attribute identifier type is 30.0.0.0.0.0.0. And here's our breakdown. Again, the first 24 bytes are going to be identical. This probably isn't the easiest to see. So blow that up a little bit more. Not so much. Sorry about this. That's a little better. Okay. So again, first 24 bytes, we got the identifier type, the length of the attribute, whether it's resident or not resident, the stream, flags, attribute identifier, the size of the resident data, and offset to the resident data. Okay, so again, that 24 bytes are going to be identical as far as what those bytes represent for every different attribute. And then our content, so again at offset 24, we start our content of the file name attribute. This gives us our MFT record number of the parent. So if you got a file, what's the MFT record for the parent folder? And the sequence number for the parent folder. And then we've got the created times, modified, MFT modified, and last access time. So these will look identical to what we saw in the standard information attribute. However, they don't get updated as frequently. So we can't rely on these dates and times. So we kind of dismiss them and just stick with whatever we read in the standard information attribute. We got some other, if this is a folder, and so a folders we call them an index. And so if this is a folder with the size, the allocated size for the folder or index, and then the actual size of the index, how much do we actually use? And then we get file type flags, reparse points, a name length, and then a name type. And so there, remember when we were in FAT, we had two different types of names. We had a long file name, we had a short file name. And so we have the similar type situation here, where we have a Win32 name, we have a POSIX name, we have a DOS name, and so the different types. And then finally we have the file name. And so the length of the file name is going to vary depending obviously on what you type, because we can have again up to 255 characters. So if the file name is too large, this may end up being a non-resident file. Unlikely, but it's possible. But again, we don't have a fixed length here because we can have, essentially up to 270 some bytes in this attribute if you had a file name that's 255 characters plus all the rest of this information. So this will vary depending on the file. So we actually have to look at that information. Okay. So let's walk through this. So yellow is our header, orange is our standard information attribute, and now blue is our file name attribute. And again, we'll see that it starts with a 30.0.0.0.0.0. So our length in this particular case, the length of the attribute is 112 bytes. So again, this is going to vary for every file name, depending on how many characters you use.
Yeah, I can send it out.
This is a resident, so the name is actually stored inside the MFT, and you'll see it down in here. You're going to see that Unicode text right there. Streams, we don't have to worry about stream names, are not associated with file name attributes. This is our second attribute. And so we've got a 02.
When I was in his class on Tuesday,
Typically, the standard information attribute is 0, and then the data attribute is 3. But again, these can vary a little bit as well. We have the size of the content. So again, we've got a 24-byte header, and then however much data we need after that to get the dates and times and the file name itself. So in this case, we need 56 bytes for the content. Our offset to the content is always going to be 24 bytes in because of our header. So here we are at our content. So we have MFT record numbers of the parent, and this will be a folder. And then we also have the sequence number of the parent. Okay. So in this case, they're both the same. The record number is 5, and that means it just happens to be the root directory. So again, that's just because I happen to remember root directory is always MFT number 5. Yeah. So 5 is a root directory, and the sequence number is the same as 5 in this case. So there we have our 4 dates and times, created, modified, MFT, last written, and last accessed. But again, we're not going to rely on these dates and times because they don't get updated regularly. Allocated size, this is a folder. This is a text file, so it's not a folder, so we're not going to have anything in these bytes. We'll have our DOS attributes, again, just like we looked at before. So a 20.0.0.0.0.0.0 means the archive bit is set. And again, that's the same that we saw in FAT. We have our reparse values. Again, we'll talk about this in the next chapter. And now we actually have our name. So we have, and this tells us how many characters we have in our name. So offset 88 is the number of bytes in the file name in Unicode. So it's telling us we have 10 bytes, 10 Unicode characters. So HEADER dot. And so in this case, we actually do count the dot and TXT. So 10 characters. Now, as far as the file name types, so here's our options. So 00 is a POSIX name. And typically we're not going to have POSIX names listed in here, but that is an option. 01 is a 132 name, which is a subset of Unicode characters. And then you have a DOS compliant or a DOS compatible name. So if it actually fits within the 8.3 rule, and is a short file name, then it's going to be a DOS compliant. So if it was a, kind of like the header ~1, that would be a DOS compliant name. In our case, we're a DOS compatible name because we actually wrote it in an 8.3 format, all caps. It's less than 8 characters, 8 or less characters for the name, and 3 characters for extension. So that is a DOS compatible name. So that's a type 3. And again, here is the name itself typed out to HEADER.TXT. And so that's our name. And so that's really the only thing we're getting out of this attribute is the file name itself. So that's all we care about out of this attribute is the name. But one thing to recognize is we can actually have multiple file name attributes. So just like having a short file name and a long file name, that's 2 file name attributes. So it will repeat the same attribute. The length will be different. So if you had a short file name, the length will be different. And then you have the long file name, which will be obviously longer content in there, but the same dates and times and information about it. But you can actually create more file names. You can have infinite number of file names pointing to the same data. And that's one of the things that's part of POSIX is allowing that. So. So here's an example of multiple file names associated with a file. So you see we have multiple 30 headers there.
Talk to him, and I'll give him your copy. Here's just one of them.
And again, these are referred to as hard links, and we'll look at hard links more later on. But that's one of the advantages of NTFS, is to have this ability for multiple names. Okay? So again, we looked at the file name attribute. It starts with a 30, and again, the header is still 24 bytes. File name attribute is typically always going to be resident in there. And then the content is going to vary in length, but it will have the 4 dates and times that are unreliable, and then the file name itself. So that's the basic makeup of the file name attribute.